Hello everyone. Again, we will study the 10.4 exercise. In the previous classes, I explained the four questions and the first question given the homework. Today I am going to start the question number 6. It is a little tough also. So before starting the question number 6, let me explain what is said in the question. You can read in your book, and I have the book, so you can refer from here also. This is the question number 6 from exercise number 10.4, and it says that this circular park of radius 20 meter is situated in the colony. There is one park. It is in the shape of circle, and it is having a radius of 20 meter, and it was there in the one colony. There were three boys, Ankur, Sayed, and David. The three boys are sitting at the equal distance. Means the distance between the Ankur and Sayed, the distance between the David and Ankur, and distance between the Ankur and the Sayed and David, they all are equal to each other, and the distance is equal to each other. And they are playing with the one toy, and they are having one telephone string. String is the string they are having in the hand to talk to each other, and we have to find what is the distance between them. Means distance between the Ankur and the Sayyid, Ankur and the David, Ankur and David and the David and the Ankur. Means all that difference between, we have to find difference between them. So for that we will see, this is, I had already made the figure on the board. You can see the board figure. This is the three boys. This is a circular park. You consider this as a circular park, and this circular park. This is the boy Ankur. I write in the bracket Ankur, and this is the B point is the another boy sitting, and the C is the David. So we have to find the distance between the Ankur to David, David to Said, and Said to Ankur. Difference. So that means we have to find difference between A to B, B to C, and A to C. But it is mentioned in the question distance between A to B, B to C, and A to C is equal. And along with that, one more thing is mentioned in the question, that radius of the circular park is the 20. So we can say that AG is the 20 meter, BG is also 20 meter, GC is also 20 meter. Why is AG is 20 meter? Because this is the radius of the circle. A to G is the radius of the circle. I already told G is the center point. From center to the circumference is the radius. Center to the circumference is radius. G to C is radius, but GD will not be the radius because it is not touching the circumference of the circle. So we can write the given information, what is said in the question. This is the 10.46 question. So according to this question, it said that there is a difference between AG, AB, BC, and AC. They all are equal to each other. The difference between A to B, B to C, A to C is equal to each other. Now this will be equal to, I am taking as the A. Means A to B, B to C, A to C is equal to A. And the radius AG, AG, BG, and GC, this is the radius. It is given in the question, it is equal to 20 meter. So this we call, and the G is the center of the circle. I already told you. Now what we will do, we will do one construction here. We will draw the, let the AD is perpendicular to BC. Let the GD or AD, let GD is perpendicular to BC. If GD is perpendicular to BC, then we can say that the BD will be equal to DC, because line drawn from the center of the circle will be equal in the bisector chord. So therefore GD will be equal to this. This came from the statement, the perpendicular drawn from the center of the circle, perpendicular drawn from the center of the circle bisect the chord. Bisect the chord. So GD equal to GD no, BD equal to DC. BD will be equal to DC. This is the line drawn from the center of circle. It will bisect the chord into two parts, BD and DC. Now B to D and D to C, they are equal. And if the BC is A, what is the value of the BD? Because B to C is A, then BD will be A upon 2, and this will be also A upon 2 because this is the half of A. So we can write BD and DC, they are equal to half of A upon 2. A upon 2 will be I written because B to C is A, and the half of the BC will be A upon 2. So this much is the given we have tried. Now to solve this question, we will take first triangle ABD. We will take the triangle ABD. So in triangle ABD, this is the triangle ABD, and this is the right angle triangle. Right angle is formed here. So this AB will be the hypotenuse side. AB square is equal to BD square plus AD square. So AB, I have already told, is equal to what? A square. BD is A upon 2. A upon 2 whole square plus AD square. So this will be equal to A square upon 4 plus AD square. Now we will find the value of AD. So A upon 4, this A square of the A is 2, A square 2 is 4. A square upon 4 is equal to AD square. Now we will take the LCM here. So 4 will be multiplied with A. 4A square minus A square upon so I am writing here. After this, it will be equal to so this AD square will be equal to AD square is equal to after we take the LCM 4A square minus A square upon 4. So AD square will be equal to 3A square upon 4. Now we will find the value of AD. It will be the square root of 3A square upon 4. Square root of 3, and from the A square A will come out, and from the 4 2 will come out. From the square root, we'll remove the square root sign. Here is the value of the AD, and from the root 3 will be in the root, A will be the outsider bracket because we have A square, A will come out, from the 4 2 will come out. So value of the AD is the root 3 upon 2A. Now we'll find the value of GD. How to find the GD? From AD you subtract AG. GD is equal to AD minus AG. AD minus AG. AD is the root 3 upon 2 A minus 20. Why 20? Because AG we have already written here. It is 20. So I am going to find the value of GD. From AD I can subtract the value of AG, so I will get the value of the GD. So GD is equal to now root 3 upon 2 minus 20. So this is the value of the GD. Now in the last step we will take the triangle BGD. We will take the triangle BGD, and from this triangle BGD we will this is a small triangle BGD. Now we will be there is a hypotenuse BG and BD and GD, so we can find the value of BD, and what is the value of BD will be equal to So to find BG square. So for that, what we have to do? I'm going to now see in triangle BGD. In triangle BGD, this is the hypotenuse side BG square is equal to BD square plus GD square. Now BG square is how much? B to G, I already told B to G is radius, 20 square. 20 square. BD is equal to how much? A upon 2. BD is A upon 2, so we'll write here A upon 2. And GD is how much? GD we have to find out here, root 3 upon A minus 20 whole square is the value of the GD. Now you can see here in triangle, I had taken one triangle, which one? BGD. In triangle BGD, I have the BG square is equal to BD plus GD square. BG square is the 20. This is my from the figure. BD we had written A upon 2 and GD I just found here. Now 20 square is the 400. A square upon 4. Now here you can apply the identity A square minus B square root 3 A upon 2 whole square plus B square 20 square minus root 3 2AB 2 into root 3 upon 2B. Value of the B is 20. Root 3 upon 2. So it will be A square, B square, 2. A value is the root 3 upon A upon 2. B value is the 20. So this will be equal to what? Now here you can write 400 as it is. A square upon 4 will be as it is now. Root 3 will be 3A square upon 4. Because root 3 square is the 3, A square is the A square, 2 square is the 4. 20 square is the 400. This 2 and 2 cancel. Here it will remain 20 root 3 A minus 20 root 3 A. Now, next what we will do, this 400 is plus positive and this 400 is negative. Both 400 has a positive sign. This 400 and 400 cancel. So now it remains here, nothing is left, 0. A square, this LCM is 4, so we can write it 4A square upon 4 plus minus 20 root 3A. Now this 4 and 4 cancel, so it is remain here A square and this minus root 3 will come this side, it will become positive. Root 3A is equal to A square. So A square we can write 20 root 3A is equal to A multiply A. This A and A cancel. A is equal to 20 root 3A. This is the value of A. If we got the value of A, then you can see from the figure, we had considered that A to B is A, B to C is also A, and A to C is A. That means distance between two Ankur to David will be also 20 root 3. 20 root 3. This is the 20 root 3 is the distance between the Ankur to David and David to Syed and Syed to Ankur. This is the difference between the all will be the same because mention the question. So we can write here distance between distance between them will be 20 root 3a. 20 root 3 a is the distance between them. 20 root 3 only. 20 root 3 and that it is a meter. So you can write here this is in the meter. and the distance between A to B, B to C, A to C, all are equal. So that means distance between, if you want to write in the distance between, you can write it here also, distance between. You can write here this way also, A to B, B to C, and A to C. All the distance between all of them will be 20 root 2. That means either between distance with the uncovered debit and the debit uncovered all will be equal to each other. 20 root 3 is the answer. So this completes question number 6. So I hope you understood this question. Now we'll see the next question. Before starting the next question, we have to study the three theorems, and on the basis of theorems, we will solve the other questions of the exercise. So first one, you see that the 10.8 theorem. 10.8 theorem. I hope you understood this question. Now 10.8 theorem says that this is the 10.8 theorem. This is the in your book it is 10.8, and you can read this theorem. The angle subtended by the arc at the center is double the angle subtended by it at any part at any point on the remaining part of the circle. It means that if the angle is formed at the center will be double than the angle formed in the remaining part of the circle. The center angle will be double than the angle formed in the remaining part of the circle. So this is the 10.8 theorem. There is one more theorem. Angle in the same segment of the circle are equal. This is 10.9. This we see. And the angle in the semicircle, because this is very less number of students found where the angle in the semicircle is given. This is given before 10.10 theorem. Angle in the semicircle is the right angle. So this is the another theorem. This will also be used. This will be used, and this is 10.8. And this 10.10 theorem is removed from the syllabus. So we will study the angle subtended by the arc at the side is double the angle found in the remaining part of the circle. Angle in the same segment of the circle are equal. Angle in the semicircle is right angle. And this 10.10 theorem is removed from the syllabus. These three theorems we have to study to solve the exercise